I done it.
We have started meeting.
In
Good evening to everyone. Can you hear me? Yep. Okay. I think let's wait for a couple of more minutes. Let's more 5 more minutes, and then I think we'll start this session. Thank you for your patience. So I think we waited for 5 more minutes, and let's respect those who have joined us on time. So warm welcome to this first webinar related to precast and the infrastructure application in India. Uh, Let me introduce to the our team, Danilo. So in this session, we will cover three major aspects of this session. One is introduction about company, what we do, who we are, and what is the role of Dramix in the steel reinforcement in the concrete. Uh, our colleague Danilo Gicinto, who is our technical manager for precast and he is a FEM expert. He will cover about SFRC characteristics and design approach towards precast, benchmark cases, and the practical aspect of SFRC. Warm welcome to our industry partner, colleague Sandeep Sharma, who is a senior business development manager from Elematic, who will cover the Elematic offerings in the field of precast. And then last, we will have Q&A session. So let's begin. Let's begin who we are. So when we talk about Bekaert, Bekaert is a global market and technology leader in the steel wire transformation and advanced coating technology. So basically what we do, we get a wire rod and we draw wire up to 1 micron. Just to give you a scale of our technology expertise, our human hair is around 50 micron. We can draw wire up to 1 micron. That's our technical capability. Let's look at some financial numbers. So Bekaert is a 5 billion euro company having presence in more than 120 countries with the support from 27,000 employees. If you look at the segment-wise coverage, a major chunk is coming from tire and automotive segment, where we have product called steel cord, which contributes around 44% of our business. The next biggest segment in our portfolio is construction, where 19% revenue is coming, and remaining like agriculture, basic material, energy utilities, equipment, and consumer goods. These are the some of the segment we have where we have a market leadership as well. So let me give you a glimpse of what we have done in last 140 years in terms of innovation and value creation. As I already mentioned that we are global leader in terms of wire transformation and coating. That indicates we are serving more than 13,500 customers across 130 countries, having plant of 68 plant across different location, which includes in-house R&D and engineering capability. When I say we are innovative company, we do have three major R&D centers. One is in Belgium, China, and India, with covering 2,300 patents, designs, and utility model. When we talk about the financial results, we have given extremely handsome returns to our stakeholders during last 5 years. And let's touch upon some of the brands in the market where Bekaert is a market leader, like Bryden, Dramix, Caranto, Arma4, and Ampact. Next. When we talk about specifically about concrete reinforcement, which is a green, smart, sustainable solution, I'm representing this division for the Indian market, and we have around 700 employees across the globe, 8 manufacturing plant, and revenue around more than 380 million. If you look at the segments, we cater major 4 segments: flooring, tunneling, mining, infrastructure, and renovation. Being a multinational company headquartered based in Belgium, our major chunk of revenue coming from Europe. However, Asia and America is also growing at a very healthy pace of growth. So, in nutshell, what we do? Traditionally, you are using some reinforcement, 1 layer or 2 layer, depending on the loading condition, and we call this is the older technology. Whereas this can be completely replaced or composite or partially replaced based on our design solution with our Dramix steel fibers. So in nutshell, we are giving you smart, sustainable, cost-effective, and labor time-saving options as compared to traditional methods. These are the glimpse of applications where it is a proven in rest of the most of the Americans and the European market, where these applications are using our Dramix steel fibers from last 40 years. Be it a pipe, be it wall, trenches, box culvert, electric cabins, so on. I think now I will call upon our technical manager, Danilo, to take us through the technology overview of SFRC more in-depth manner. Floor is yours, Danilo.
Good afternoon, everyone. Thank you, Arun, for the introduction. It is for me a pleasure to talk about SFRC in this webinar. I'm Danilo Di Giacinto, and I'm a technical manager for steel fiber reinforced concrete precast application at Bekaert. I'm a chartered civil engineer, and I have a master in civil engineering, also a PhD in structural engineering. I have been working both as a structural engineer and a researcher in Europe and the US for 15 years now. And today I will cover the technical aspects for SFRC, including the design of structural members. Let's start with a few concepts. What is a steel fiber? What you see in the fingers of the guy here on the left of the image, this is a fiber. This is actually our most performing fiber, the 5D. but I will introduce the Dramix family in a few seconds. What is a steel fiber? It's a relatively short 1D steel elements that you can mix within your concrete mix, basically, and to achieve what we call a concrete reinforcement, a structural concrete reinforcement. Few milestones of Dramix, since Dramix is one of the most copied construction products all over the world. It has been invented as a hooked fiber, so improved anchoring mechanism in 1970. In 1974, to avoid bonding of steel fibers, we invented the concept of glued fibers. So the fibers are packed in bundles to improve the workability of within the concrete mix. And in the glue, we have a special inhibitor for the zinc coated fiber. And indeed, the zinc coating, environmental friendly, very important because we care about sustainability. We introduced it in 2004 to offer a galvanized solution, so a rust-free fibers, which is really important for precast elements. While in 2012, we introduced the very performing fibers in the market today, the 4D and the 5D. And today and towards the future, we have the premium high tensile fibers. For example, we have a short fiber which can be used even for the UHPC application, in which the wire strength can go up to 3070 MPa, which, believe me, is a very high value for a steel wire. A little bit about the Dramix family. We divided the fibers, steel fibers, in three categories: 3D for typical SFRC application. So, for example, flooring in either fiber only or combined solution. 4D family with an advanced hook system with the two basically bends at the end of the fiber, in which we can achieve a supreme serviceability control. And lastly, the 5D fibers with advanced structural application, a very advanced anchoring system. Just to give you an indication, with a single 5D fibers, thanks to the wire strength, which is the main improvement of this fiber type, together with the advanced hook, we can achieve to withstand a weight of 150 kg. What happens when you add fibers to your concrete? Being a reinforcement for your concrete, you can eliminate or reduce the traditional reinforcement in the form of mesh or rebars. So you can have either a faster and safer construction, actually both the features you can achieve. You can have an homogeneous distribution because the 3D network of fibers is a uniform reinforcement in your concrete structures. So, for example, specifically for precast, spalling, the presence of part of concrete which is not reinforced, which can lead to problems in the aesthetic of your precast element, can be avoided. So you have an element which is reinforced in every point. And indeed, thanks to the very advanced hooking system and wire strength, steel fibers from Bekaert, Dramix, can be used for structural application, both in fiber only or combined solution, which can include both rebars, mesh, but also post tensioning. What are the typical structural application, for example, are foundation slabs, rafts, suspended structures, or heavy duty precast elements like bridge girders or, for example, roofing elements. How does SFRC work? This is a very important concept. When you add fibers to your concrete, you have a new material, a composite material, which a concept which is totally different from the standard reinforced solution. You have reinforcement everywhere, and as soon as a crack appears, The steel fiber can bridge it. The cracking can be more distributed. You have thinner cracks. You have the spacing between the cracks, which is smaller. And thanks to this feature, so because we can achieve the bridging of cracks in the early strength, we can improve the strength, the toughness, the ductility of the concrete, and obviously also the durability. Because the main difference between the traditional concrete is that you don't have any concrete cover. Even what you can call the concrete cover is reinforced, so durability is enhanced. Smaller cracks, cracks are more close. The cracking mechanism is improved, so the durability of the structure is improved. Also, there is an improvement in resistance to impact and dynamic loads. Given the fact that fibers can bridge the cracks, you have a redistribution of stress. So internal forces are distributed better, both in terms of bending moments and shear force. Thanks to that, labor reinforcement detailing, so the guy that is behind the computer detailing the bending schedule of the structure, the materials, the utilities in a precast factory, the warehouse occupancy are reduced, and also from a sustainability point of view, the embedded CO2 is also reduced because we can have a thinner cross-section, we can have less steel, so as a consequence, the embodied carbon is reduced. What changes between plain concrete, so not reinforced, and Elematic with the reinforcement already in it, a uniform reinforcement like steel fibers? For traditional concrete, when you reach the elastic limit, you have cracking and the structure cannot withstand any load anymore. So you have a brittle structure, you have wide cracks, and your structure collapses. With SFRC, a typical SFRC, a standard SFRC, consider a dosage between 20 to 50 kg of fibers per cubic meter for concrete classes, compressive strength between 20 and 55 MPa, but it can go up to C90 for heavy ducty structures, like for example, bridge girders. You can achieve either a softening behavior or a hardening behavior. What is a softening behavior? It basically when you achieve the cracking strength, your structure cracks, and the load, you cannot achieve a higher load, but you can have a ductile structure. So the collapse is not brittle as in for plain concrete. You have a ductile behavior, and when you have a hardening behavior, you can even achieve a load which is higher than the cracking load. So after the cracking, you have a controlled cracking of the in your structure. Fibers can bridge cracks, new cracks, early cracks, and there is an improvement of the post-cracking. Here, a lot of concepts, but to put it in a nutshell, I already talked you about our fiber families, 3D, 4D, and 5D, but what changes when it comes to numbers? The wire strength is different. Obviously, an advanced fiber has a wire strength, a base wire strength, which is higher than, for example, for a 5D than a 3D. For 5D, we can achieve up to 2,300 MPa of wire strength. For a 3D, is around 1,200. A 4D fiber have an intermediate base wire strength. When it comes to normal wire, we also have another family of 4D fibers, premium fibers with high tensile wire strength. But when it comes to the behavior of fiber within the mixed design, within a concrete mix, we can have two different kind of behavior: the pull-out mechanism, and we can see later on the flexural mechanism. When it comes to pull-out, which is basically you take the fiber from the extreme part and you pull it from your concrete, you can have different behavior, and it depends on the wire tensor strength, on the hooking mechanism, and on the base concrete strength and compressive strength. For example, with the 5D fibers, we can have a hardening behavior again, which can allow to achieve up to 140% more pull-out strength compared to, for example, in 3D fibers. So the 5 main points for the Dramix fibers are actually the tensile strength of the steel, which can be wide, which can be very different according to the fiber type, the anchoring mechanism. So the type of anchors at the end of your fiber, which can lead to different mechanisms. The performance class of the fiber itself, that depends on the length of the fiber and on the diameter of the wire. The fact that it's a homogeneous reinforcement, and thanks to the zinc coating, we can have rust corrosion protection. How you characterize your SFRC performances, so the toughness of the material. There are several standardized tests. For example, this is a very important test which is used worldwide, but is a European standard. When you do a flexural 3-point flexural bending test on standardized beam with an initiated cracking path. So you have the notch in the middle of the beam in which the crack is initiated. What do you get? You get some curves. This is a typical curves with the load on the y-axis and the CMOD on the x-axis. CMOD is the crack mouth opening displacement. So basically the distance between the two faces of the initiated cracks of the notch. And you have, according to the standard, different residual strength value. What are those points? According to the standards, are residual strength values. So what the flexural strength values after the cracking stage. This is the limit of proportionality, which depends basically on the matrix. Then it is standardized. You have FR1 to FR4 values. FR1 is typically associated to serviceability limit state, while FR3, so 2.5 millimeter CMOD, is associated to the ultimate limit state. And the steel fiber reinforced concrete, according to the dosage, the steel fiber type, the base concrete strength, can have different behavior. It can be softening, it can be hardening, and it depends on the fiber performance. The more advanced is the fiber, so the more advanced is the hooking mechanism, the anchoring mechanism. The more advanced is the tensile wire strength, so the strongest the wire, the better the performance within the concrete. With the 5D and 4D, you can also have structural application with fiber-only fibers. Some basis of design, because at the end of the day, we have to design our structures. How we design our structures with SFRC? It's a moment, it's a cross-sectional analysis for the moment capacity. Everything is covered by standards. The more important are listed here in these slides, and the main document is the model code. Now the model code 2010, which is active at the moment, is going to be replaced by model code 2020, in which there are some changes, not important from a moment capacity point of view, actually. And also there are other very important documents, for example, the Rheinland document, the German standard, which is very comprehensive and covering several aspects of the design of SFRC. In Bekaert, we can help you in covering every kind of standards concerning SFRC. We have even an IAPMO in North America for covering the ACI 318 requirements. And at the end, when it comes to design, it's passing from a flexural behavior to a tension behavior. This is what you use in cross-sectional design to get the moment capacity, and for passing to from the flexural behavior. So what you get from characterization of the material, the three-point bending test I showed previously, to the tensile load, which is what you use for the concrete below the neutral axis. It's just a matter of applying the right coefficients. Those coefficients are listed in the standards that you are using. And obviously, we have a very vast background and experience on that, and we can help you on that. This is a typical curve for SFRC, and those are the values we use, and we have also in our database for allowing you to start a design before dealing with your concrete needs. So you can have an idea of, for example, if you have an element for which you are curious to understand if it's worth to have an SFRC solution for having more economical solution, more performing, more durable solution with the improved performances. We have a vast database to start with. This is a nice slide with two tensile load. This is used typically for linear analysis. This is used typically for nonlinear analysis. And those tensile loads comes from the German standard, which I told you is very comprehensive and covering every aspect of SFRC. You can see here the coefficients I was talking you about previously, and those coefficients depends on the properties of your concrete, the element you are investigating, and those are listed, and there are very simple formulation to handle and convert residual flexural strength value to tensile load, and at the end to the design values you will use for your design. So at the end of the day, it's just a cross-sectional analysis for flexural capacity. How you do that? Very simple. We have tools. We have the Dramix Pro suite with several tools. One of them is the moment capacity tool, covering several standards, covering several residual strength value coming from the compressive strength and from the fiber type and the dosage. And also we have tools for covering the shear force, the shear capacity of fibers. For shear is even more, let's say, intuitive to use fibers, because shear is a brittle mechanism. When you use fiber, you have a ductile mechanism for shear. You can avoid using the transversal reinforcement, and fibers can bridge also shear cracks. Here, for example, no shear reinforcement. You have a narrow cracking path, while here you have a more wide cracking path with smaller cracks with controller mechanism. So this structure here reinforcement with the fibers, it's more ductile than this structure here with no shear reinforcement. You can achieve something like that with the stirrups, for example, but with fibers you can achieve at the same time with the same material both flexural and shear capacity. Some slides on how we approach precast design. Because as Bekaert, we provide technical support with global coverage, covering several segments, infrastructures, which include precast, tunneling and mining, flooring and renovation. We have 3 concrete labs. The main one is in Belgium, where we have the HQ. We have also a lab in India and a lab in China. We have a vast team of technical innovation manager and also sales engineer, technical people helping you on the design of SFRC. And we have also a sister company in Germany, Falconix, which is a design office and can provide liability, official design. We have also a vast experience in in-house design of precast elements, also in flooring, but I'm the technical manager for precast, so let me deal with precast. Vast experience covering the entire world, covering several types of elements, So stormwater elements, stormwater control elements, pipes, box culverts, U-drains, manholes, modular structures, so houses, electric cabins, backpots, facade and panels, so 2D structures, both solid and sandwich, so with the structural part and an architectural part, and special elements. Those are an infinite list of elements like retaining walls, masts for wind towers or foundation elements, vertical shaft, whatever. As for our Bekaert design expertise, we use the different design tools, both commercial and proprietary. For the commercial part, we have a partnership with the SIA, for example, SIA Engineer, which is a software widely used in Europe. We have also a partnership with Adapt and Global in Germany. And for very advanced models, we can use Abacus. When it comes to Dramix Pro, so our tool, which are free of use for the customer, we have several tools. For Precast, the more important are the moment capacity and the shear capacity. What we can offer design services also with liability thanks to our sister company in Germany. We can offer technical advice. We have people coming to your field, to your factory, helping you with your mix design, with the practicalities for SFRC. We can give access and training to our Dramix Pro tools, and we can help with your own design cases when you want to design your own structure through the second eye principle. How the tools work? Very simple, Excel based, several options. For example, this is the moment capacity tool. You can choose several geometry type. For example, this is a slab, but it can be a beam, a circular beam or a rectangular beam, for example. You can use the fiber only or combined approach. Several constituent law model according to the standard you want to use. For example, here the model code 2010. Then the safety level that can be ULS or SLS, and in this case, what changes is this partial safety. When it comes to the concrete, fiber reinforced concrete, according to the concrete class, the compressive strength of the material, the software automatically gives you the fiber which is suitable for that concrete. For example, here, being a 5D structural fiber and with advanced hook, you need a very good compressive strength for taking advantage of that fiber. You can have, for example, a calculation based on dosage. From 20 to 35. Also, we can select a different residual flexural strength according, for example, with your residual flexural strength values coming from your mix with our fibers in your mix and the characterization in either our lab or the lab you choose. Shear capacity, same concept. Beam type, for example, here, this is shear according to German standard, fiber only, concrete plus fiber type. Characteristic factor, this is something that requires more in-depth knowledge, but we are here to help you. And if you are curious about that, just knock our door. We are there to help you. Dosage, calculation based on dosage, very simple, just with the dosage, which can be something that can vary according to the your TCO, your total cost of ownership. You can just have your shear capacity. And believe me, for this beam, this shear capacity is pretty high. So for most of the cases, steel fibers can cover most of your shear demand. How do we design elements? For example, here, this is a MNO, fiber only. We have a partnership with SIA. Just normal design, normal finite element analysis modeling, the element with the mesh, the support condition, the load, lead loads, permanent loads, and horizontal loads. In the software, you can select the concrete, the Dramix type, and the dosage for checking the structure. Or you can just have the dosage calculation, the automatic dosage calculation based on your loads and your load combination. For example, here this is the ultimate input state. Here you have some minor numerical issues, but this manhole can be made with 20 kg or 40 fibers easily. Also, you can have the moment capacity, so you can compare with the occurring bending. Some benchmark cases, pipes. Pipes are the most manufactured precast element. Typically, for characterize the strength of your pipe, sorry, you perform some kind of test, crashing test. The most used one is the three-edge bearing test. For example, according to the European standard, the 1916 or American standards. And for steel fibers, you have to hold 67% of your design load, which is what you want to achieve to assign a specific load class to your pipe for 1 minute without any cracks. Then you increase the load up to a ultimate load, which has to be higher than the design load, and to drop to zero, load again and withstand the same 60% of the design load for another minute. You can achieve that very easily. Indeed, here we have a pipe 1200 millimeter, load class 135 kilonewton. This is a standard reinforced pipe, so one mesh. This is a SFRC pipe with our Dramix. You can clearly see the difference in the cracking pattern. The load is pretty much the same, the load capacity, but cracks here are wide. Cracks here are very small. We have some micro cracks here for 100 millimeter, just 0.1 millimeter thick. So basically, you achieve, even at the crushing load, you achieve wider tightness. What does it mean? Improved durability, less cost of your infrastructure, and happy customer. Case study number two. This is a box culvert. Again, fiber-only solution, 25 kg or 5D 6560 GG galvanized fiber. This is in the box culvert in Belgium. The box culvert is 1200 millimeter wide, 600 millimeter high, and the test to assign the load class and to achieve the requirements are given by the European standard 14844. What we did here, we did to optimize the resources for testing and nonlinear analysis with C engineer again, with as an input both the compressive strength according to the Eurocode and the tensile load according to the German standard. This is the model, very easy, with incremental load up to 200 kilonewton per line. And this is the real test. You can see here that even after failure, the structure almost reached 500 kilonewton with some pretty good ductility. Even here at failure, you don't have any stalling of the concrete, any segment that is cut off, and the structure looks pretty good even as a fail, when the structure is theoretically collapsed. So you can see the collapse in terms of load, but not as a structure which is completely destroyed. This is thanks to the fibers. This is a fiber-only solution, so just 25 kg of Dramix. No spalling, reduce it crack with traditional, compared with traditional solution. And more important, the client can manufacture this pipe and sell it according to the code. Some practical aspects. Using fibers in your concrete is not impacting your day-to-day activities. So your process remains the same. You can add fibers either at the batching plant or, for example, in the mixing truck. So the process is more easy than you may think. It's just like adding another aggregate into your mix. We are there to support you with the design, with the practicabilities, with improving your mix design using fibers. We can support you in every technical aspect of SFRC. Now, it is a pleasure for me to hand over to Mr. Sandeep Sharma, which is the Senior Business Development Manager at our industry partner, Elematic. Sandeep, the floor is yours.
Yeah. Thank you guys for making such a nice presentation about Bekaert offerings. And it is my pleasure to present Elematic offerings for precast industry. I'll be sharing a presentation about Elematic's offering and what we are already doing overseas and in the market. I hope you can see my screen.
Yes,
So
we can. Yes.
I'll just give a brief about Elematic. We are a Finland-based company having headquarters in Finland. It's almost 65-year-old company. We have our presence in more than 100 countries, and we hold almost 70% market in terms of supplying precast plants all across the world. We started our journey from 1959, and it is a small history of Elematic. In India, we have our presence from 2009 onwards, and we provide all turnkey solutions from building design to factory installation, from supplying of the precast plant, training the client resources, so complete handholding support to set up a precast plant. Our office is based at New Delhi. We have a design solution office at Pune and Gurgaon. We are having manufacturing at Alwar, and some of my colleagues working from home, marketing representative from Bangalore, Hyderabad, and Ahmedabad. We have a very great team. We are providing very expertise solutions for precast and steel structure design services. We have a almost 50 plus people team, and we are using all the standard licenses of software like Tekla, Revit, and we do all the work on 3D BIM platform. This is one of the iconic project which is rightly going on at Hyderabad. It's like 7 basement and 34-story building. It's a commercial building project, and the client is executing this project in like complete precast, and they are doing 4 million square feet built up area every year. This project is almost like 39 million square feet at single location. So I'll take a brief to explain what is precast. I'm sure everybody is aware of precast technology. So in precast, design and planning is very key, and we spend almost 50% of the project time in design and planning, because once the design is freeze, only then we can proceed with the actual production. So design, production, curing, and storage is done on off-site construction methodology in a factory environment. Then we transport precast element at site, install, and then do the finishing. So there are a lot of advantage of precast construction over the Maivan construction or traditional construction method. So one of the best advantage is timeline. So one can finish any project in any time duration. So we say that at least 50% time saving you can get. If we plan efficiently, then definitely we can save a lot of material saving also, and we can definitely execute any project with 1/3 of the project because it's a mechanized construction, and there are a lot of other advantages also. So when we are doing any residential building, we try to construct this building without column and beams. So we can do up to 20-story building and different seismic areas. We are doing the load bearing wall system and pre-stress hollow core slabs, giving it a long span. Design is very important precast, because if we do the efficient design, then it is very economical. Here in this layout, you can see only these bold lines are load bearing walls, And then internally you can do any kind of changes. So it is very flexible construction. When we talk about precast construction, we have these different kind of elements like this precast walls, sandwich wall panels, aquatic partition walls, staircase, various type of half slabs, these hollow core slabs. So here you can see we have hollow core sections from 160 mm to 500 mm. So more thickness you are going, you are able to save more material. So with this hollow core slab, we can give from like 4 meter up to 18-20 meter span very easily. These are ready to install precast stairs, column and beams also. So I will show you some of the project which our customers have already executed in India. So these are hostel building at Sonipat. They have done more than 5 million square these kind of projects in last couple of years. And the building is so beautiful that they have not painted these buildings. Recently, they did one building around 6 lakh square feet area with all the services, and they handed over to the client, means their university, in 5 months time only. Similarly, another project at Pune, this is 4 million square feet project, 15-story building. Here you can see a very few people working. This is like live construction pictures. So work is done through the cranes and very few people required site. There is no column and beams, load bearing walls and slabs. And here you can see in the background, they have this factory. So the capacity is around 1.5 million square feet every year. Another project at Bangalore, this 9-story building. You can see that this building is planned very efficiently. There are very few precast elements in the building, and the coefficients of the concrete and steel are very lesser. It doesn't include foundation. This is massive project. It happened at Delhi. This was done by BG Shirke. They did around 1 lakh houses in 6 years. So this project was having from G+5 up to G+20 story building in seizing zone area 4, like in Delhi. So again, you can do any kind of projects if were proper planning and proper execution. A very good project in Naya Raipur. They did around 6,200 apartment project in 3 years time. We can do one villa every 15 days with this kind of precast plant, and the quality of construction is very nice. So now I'll show some examples in high-rise commercial buildings. So this project happened at Hyderabad. It was having 4 basement and above like 25-story buildings. So it was total 1.9 million square feet area. This project was executed by Aurobindo Realty at Hyderabad. They executed this project from scratch to finish in 2 years. They were having around 12 meters span this building. Another project of the same customer, 11 million square feet, 11 lakh square feet. In Hyderabad, Bangalore, this is Embassy project. So all the buildings require 5 basic elements: column, beam, slab, walls. So you can make any kind of buildings using precast. This is another hospital building, and here, like, very interesting thing, like you can see the facade. This is not paint, this is in concrete. So you can make these kind of architectural finishes also very nice. So picture from inside of this building. Another project at Kochi, and this precast elements was produced in Bangalore and transported at Kochi. So normally people have this myth that precast is very expensive in terms of transportation, but they transport this element for 350 kilometers. Some school buildings using precast technology. And here you can see the facade having image of Mr. APJ Abdul Kalam. This was also this is also not a color concrete. This is not a paint. So this is kind of engraved in a concrete. So we can give any kind of logo, special graphics or pictures in the concrete itself. So the beauty of this thing is it is never get old. You can just wash it and it is like a brand new. You can make any kind of industrial building or warehouses from scratch to finish using precast. Normally people do the PEB buildings, but the substructure is conventional, so it is already delayed. But in precast, we can make the substructure also in precast. Some of our customers, they are doing already a lot of warehouses building in precast. So recently they did around 2 lakh square feet area in 3 months time. So foundation is precast, tie beam is precast, and all these facade walls under the shed you can make in precast. So and also like any factory where you have these kind of cranes, it is almost 15 to 20% economical than PB buildings, because we can save lot of material when you do these precast elements. You can make these kind of mezzanine floors with the hollow core slabs. We can also provide these facade cladding panels in precast. You can make these kind of infrastructure, boundary walls, these footings, trenches, also using the precast technology. We have a lot of to talk about precast technology, but yes, we have very limited time. We will be glad to assist you. If you have any inquiry, you can reach us directly. Yeah, thank you.
Thank you, Sandeep.
Yes, Danilo, there are some questions. Sir C.N. Sridhara is asking, sometimes while vibrating with shutter vibration, the fiber coming up or segregate one place. How to overcome these issues?
Okay, well, this is an issue that typically comes with the loose fibers. With the good fiber, you don't have this type of issue actually, because workability within the concrete is improved in the mixing stage. So you have a uniform fiber distribution, and also it's a matter of checking your mix design. So with the right mix, you don't have to vibrate too much. So right mix, we can check it with you. We can help you reviewing it. The coarse aggregate, for example, the fine aggregate, the right fiber. So by a fiber which is good workability, uniform distribution, even distribution, and you don't have this issue. You don't have to vibrate a lot, and no segregation, not fabrics coming up. Also, when it comes to fiber distribution, you have to think that even in dry concrete, in Europe, we use 45 kg of hook long fiber. So our bundled fibers are very good in having a good workability of your mix. Any other question, Sahib?
Sir was asking, is there a technical help available in India? If available, share contact details. Sir, I have already dropped you a message in the same section. You may refer this email address to raise any of your technical queries. I think that's it. Yeah.
Okay, thanks for joining us. I think this is the first webinar in India. I think response is pretty good, and we would like to take this opportunity to thank you who has joined us and spent some time with us. And we are more eager to get in touch with those who are having ongoing projects or queries related to SFRC, and also with the help of Elematic, we can help you out with the precast building precast warehouses. They are quite experts, and we are expert in the field of SFRC, and that's why this collaboration will give us edge, which is a new technology altogether in India. Even though it is a 1972 patent, Danilo mentioned, still it is a new technology. But I think progressive mind like you, who has joined this session, we would like to thank you for your time, and looking forward to have a one-to-one interaction with you guys. Thank you so much, Dan. Have a nice day ahead. Bye.
Thank you. Bye.
Bye-bye.